Welcome to another Block screencast. In this screencast we're going to complete and round out our journey of CosmWasm Rust-based smart contract development using the CosmWasm book. In this video we're going to just go through this chapter here on good practices. We will see some good tips and tricks that you should follow when building smart contracts in CosmWasm and using Rust. Just as a reminder, a lot of these good practices are already included in the CW template, which is this repository here. So this book that we're following and this course is more about getting understanding on building smart contracts, but when you come to build smart contracts using CosmWasm, you'll probably start with this template here. So without further ado, let's jump into this chapter and round out our intro. So one last thing we want to just take a look at is the ability to generate a JSON schema for our contract. You can think of this as a bit like the ABI in Solidity. When we compile a Solidity contract, we generate an ABI. That is the application interface that we can use to interact with our contracts. Similarly, what we want to do with our contract with Rust and CosmWasm is to generate an ABI based on the messages, that is, these messages here that we've got in our message.rs. So if I collapse this, we can easily, or a little bit more easily, see what the messages are. So we've got greet, we've got query, we've got appends list, we've got instantiate, and we've got execute message. So in order to make it clear that we want to interface with our contract using these message types, we can generate a JSON schema. Now, we can do this by hand, or we can use a crate to do that. So the first thing we need to do is add a new crate type to our project, which is this rlib. And we're doing this so that we can generate a schema from our code. So let's first of all do that. We can go into our message and we can add a new derive for all the messages. So that is this one here, JSON schema. Now it's getting a bit unwieldy here because we've got so many derives. Apparently there is a neater way of doing this, which is to just use this CosmWasm schema CW serd, which will bring in all of these for us in one fail swoop here. So let's use that instead. Cool. So let's see now. We've got this, and then we would replace all of these with just this. Okay, so I've added this extra CW serd and query response, and I've added this attribute to the query messages. So essentially what this is doing is it's adding all of these derives. So it can serialize, deserialize, it has partially equal and debug for the testing, it allows clone, and it also allows JSON schema to be generated from this. Moreover, we're making sure that everything is snake case when we generate the schema. So this is a shorthand way of doing all of that. And we also derive query responses for the query messages to correlate the message variants with responses that we would generate for them. In other words, this allows us to generate the correct schema for the query responses, greet and admin list. This ties everything together for our API essentially. So because we're going to use the message module for accessing crates, we want to make this public, so we're going to add this to our lib. Actually, well, it's made all of them public, so let's just copy paste that in. So now we can create some kind of utility tool, basically a Rust binary that we can run to create our JSON API schema. We're going to do this by creating a new file called schema.rs in a folder called bin. I believe we put it under source, so I'm going to put this in bin here, and then schema.rs. And inside that file, I'm going to drop this code. And so basically takes the different message types and the schema, write API function, and it's actually a macro. And it's going to call that macro in the main function with these three types of messages. So Cargo is smart enough to recognize that files in the src bin directory as utility binaries for the crate. So now we can generate our schema by running cargo run schema. Let's try that. Okay, cool. It exported the full API. We can see that it put it into schema contract. Let's have a look here. Got raw. Let's have a look at the schema that it generated. So what do we have here? We've got contract name, contract version, schema type, and then we've got the title, stands to get message, it's an object, it requires admins and denomination. The properties are admins, which is an array of string, and the denom is just a string. So yeah, it's pretty much exactly like an ABI that we see in Solidity, except we had to write, at least in this example, we had to write our own boilerplate code to generate it. So whereas with Solidity, this just comes out of the box, right? You get an ABI, you get artifacts automatically. But anyway, it's good to know. So apparently creating this binary makes the project fail to compile on the WASM target. So let's just see that before we fix it. So if I do cargo WASM, we do indeed get errors. As you can see, it's highlighting this as a source of error, the bin Rust executable that we added. So what we need to do is just change our alias in our CosmWasm, in our cargo config, such that we only build the WASM target as a library, which tells the toolchain to build only the library and skip any binaries. So that means it won't try to look at the binary here. So let's go into our cargo config and add the --lib flag, and then we can try to run that again, and it worked. So it's simple enough, right? And while we're at it, we'll add another alias, which is schema. And now we can run cargo schema, and that generates our schema for us. Awesome. And that completes our set of videos for CosmWasm using Rust-based smart contracts following the CosmWasm book. I hope you enjoyed this series, and I hope you learnt a lot and followed along with me, and I hope you've read the Rust programming book, the CosmWasm book, and that you are going to have a great journey in Rust smart contract development with CosmWasm or on other types of platforms. And I'll see you in the next video series. Thank you so much. Bye-bye.